Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
And developing community resources based around Rotor. I'd like to introduce the first talk, Elizabeth White, who I had the pleasure of watching give a version of this talk at SSCLI earlier this year, correct? Elizabeth joined the George Mason University faculty in 1994 and is currently an associate professor of computer science. She received bachelor's and master's degrees from the College of William and Mary in 1985 and 1986, respectively, and MS and PhD degrees from the University of Maryland in 1990 and 1996, respectively, all in computer science. Her research interests include software architecture, compilers, dynamic reconfiguration, and distributed software systems. Her teaching and curriculum development has been primarily in the areas of compilers and programming languages. Some of her early efforts involved the development of software that allowed visualization of bottom-up parsing and attribute synthesis for YAC grammars. More recently, she's been working on ways to use real compilers to illustrate concepts in standard compiler classes, which is the focus of this work.
Thank you. You did switch it, okay. For those of you who don't know, George Mason University is in Fairfax, Virginia, and if you're geographically challenged like I am, that's right near Washington, D.C., which is on the other end of the other coast from where we are right now. I've been teaching compilers, both graduate and undergraduate, for about 10 or 11 years now. Actually, I understand there are a number of both current and recovering compiler professors in here today. So then you all understand what is done in a typical graduate compiler class. There's a lot of theory. We get to talk about bottom-up parsing, top-down, all kinds of good, fun stuff. There's also a lot of programming. You make them build something, typically a small compiler of some sort. So it's got all the good things, both theory and programming. Now, one thing they typically don't have, or you typically don't do in graduate compilers, is use some kind of a real compiler. And I don't know if it's entirely historical. Again, I'm a very traditional compiler professor, I guess. But real compilers are big and they're ugly. Anybody who's looked inside one knows this. The Rotor C# compiler, for example, is about 200,000 lines of C++. 138 modules. So it's fairly large. You don't just sort of hand it over to a student and say, go figure out what's going on. Having said that, about 2 years ago, Ron Johnson, who is I guess his title here is a educational evangelist, is that the current title? Came and said, why don't you use some real compilers? And let's start with grad students. Why don't you use real compilers there? Let them actually see a little bit of hands-on stuff with real compilers. And I was initially a little bit resistant, but he kept coming back and talking and talking. And finally, we sort of hit upon a way to maybe try to do this, to really bring a little bit of real compiler into the class. And the idea there was to find an approach that let us just sort of show them pieces at a time, pieces that were tied directly into the theory that we were trying to teach in this class, and hide the rest. Now, as soon as you start talking about it this way, an obvious approach comes to mind, and that's to use a debugger on the compiler itself. So what we wanted to try to do is come up with sort of these exercises, these demos, these sort of self-contained I guess demos probably is the best word, that the students could run. They would be told what breakpoints, what the input files are, what variables were of interest, and they would run these basically they have a worksheet to go with it and answer questions and do that kind of thing. And so we decided to try this out. We wanted them to be able to do sort of like what's here on this graph. We've got down here at the bottom, I guess almost in the center, is a VisualStudio.net window, which you may or may not recognize. This is my first experience with VisualStudio.net, so I had to learn all this along with my students the first time anyway. And sort of underneath that is sort of the standard compiler architecture. If you've ever taught compilers, you've drawn that on the board or a slide or something like that. And the idea here, this is actually showing you what maybe a demo that displays some of the concepts behind lexical analysis, what that might look like. So you can see in red there, there's the scanner part of the compiler, and there's code associated with that, obviously. So the student sees this Visual Studio window. They have instructions on breakpoints, these kinds of things. They're given input files, and they sit there and they run this. Hopefully, they can, if they actually are meticulous about it, they can actually see these concepts right up front, right there inside the compiler code. And hopefully as well, more importantly, once they see these things, they can do further exploration. They can see, you know, this is going on. I wonder what happens if you do this or do this or this. So that was sort of where we started. We wanted to come up with something that let us do exactly this. Now, turns out this was, you know, although it wasn't a sort of intellectually hard exercise, there's a lot of work to be done in order to build something like this. So what do you do when you've got a lot of work and you're a professor? You find a graduate student. And so I had a graduate student who basically dug through many of the parts of the compilers, and her goal was to try to tie the compiler code itself right back into the kinds of things we taught in class. I have two demos that I actually do use in class now. We have more demos than that. But I have two that I actually use in class. One is tied into lexical analysis, and I'm actually going to show you this here in a minute. We also have a demo for parsing. And what's nice actually about this parsing demo, and one reason why I like using it, is because when I teach compilers, and I have them actually build compilers, they tend to use tools. They use something like Yak, which is an LR parser. But what's nice about this parser here inside the Rotor C# compiler, which is the compiler we chose to work with, is that it's a top-down parser. It's recursive descent. So it's different from the approach that they actually implement. So it gives them some experience with that. And although I usually do have them write some small recursive descent piece of software, this is a real compiler, and it's really recursive descent. So they get to not only watch it go, they can actually sort of watch the parse tree as it builds and so forth. So it's kind of a nice demo as well. But it's a little bit harder to see. So the demo I'm going to show you, and again, it's targeted at students. It's a lexical analysis demo. They get to watch some variables while they parse. There's an input file. They get to watch how the input file changes, which I'll show you in a minute. They also get to watch as tokens get identified. So an input symbol at a time, they watch it cycle through. Now, the Lexer code itself is what they're looking at. It's a little less than 1,000 lines in the code. So one of the reasons for telling you this is so you realize that just sort of handing them the code might not be the best approach. Some students would do great with that, right? We all know those students. But that's not necessarily the case for all of my students. Compilers is a required class. So not all of my students are as motivated as you might like. Another nice feature of this, by the way, is that the Lexer is hand-coded. So unlike when you go and have them build some kind of lexical code using a tool like Lex, that's that big table. I don't know if anyone's ever looked at Lex code. I always make my students do it once, and it's only a little bit of code and then these massive tables. So it's hard to see what's going on. You really couldn't run a debugger on top of the Lex code and really be able to get a good clean picture of what's going on. But the scanner in this particular compiler is hand-coded, so it's you actually look at the C code that says if this, if that, and so on. So this actually is set up just to begin. Obviously, the top part is the code itself for the scanner, and I think we're fairly we're not very far. Oh, I don't have my line count stuff up. It's like I don't know what line of code we're at. This middle window down here. I guess it's the bottom window since I got rid of the call stack. But the middle window actually shows the variables that they watch as they parse. And I know it's hard to see from here. And actually, I have another reason for making you watch this. But you can actually see down here at the first line, that long line, it's got little boxes in it and so on. It is the rest of the input. Now, the input file I give them for this demo is not actually legal C# code. And I want them to see that the scanner still works. It doesn't care about the legality of the code. It just cares about the tokens themselves. So there's actually a strange, warped reason why I give them that. But they can see various different tokens and comments, that kind of thing. And they also watch this variable that keeps track of what token they see. Now, one nice feature of this debugger is that as these variables here change, which you'll see happen here in a second, they turn red, so the student can see what's going on. And I don't know if you noticed, I hit a key and it moved forward one line. It took a piece of the input out, so they get to see watch the breakpoints as they move. Now there are only 6 breakpoints in this particular demo, and I'm not going to make you sit through all of it like I make my students. But it's very simple to run. You just keep hitting keys. Even a professor can do it. Here, I guess I'm looking. It finds the if token. It sees the IF, and as soon as it sees the space, it says, OK, I got a token. I like it. The next couple of characters are IF, FF, and so it's going to grab that in a couple of steps. It's going to look at various things. Oops, I'm looking for white space first. Then it's going to start the IFF token and find that as an identifier, although for some reason now I'm getting that. But it just goes through. You watch the input change one at a time. And so the student goes through it. And part of the exercise includes questions that they're supposed to answer as they go along. Some of those questions are fairly easy. They can just glance at the code. Others, they have to move around a little bit in the code and the surrounding code and see what happened and think about what happened before, speculate on what's going to happen next, and so on. So I won't inflict any more of that on you, although I know you want to watch the rest. If you want to see the whole demo, actually I have both the parsing demo and the lexical demo. If you really, I don't want to use the word bored, but if you really want to see it, I'm happy to show it to you. But I suspect most, you're not going to get anything educational out of it. But again, it's a hand-coded lexer, so the students actually get to look at all that C++ code, peek at variables, and so forth. Now, we developed this approach, and it was developed when I was talking with Ranjan Sen. He wanted, as much as possible, me to bring it directly into the classroom. Now, you've seen it here on the board, and now you see why my initial reaction is I don't want to bring it directly in the classroom. It's not very easy to watch, particularly at this distance. It actually isn't so bad in some kind of a directed exercise, sit down, do it at your own pace kind of thing. And that's actually how I've primarily been using it. The classroom approach, even a couple of you were glazing over. I noticed these things, but not everybody. But you're being polite, I suspect. My students don't feel obligated to be polite all the time. So I've noticed when I do put it up on the board, it doesn't really go over all that well necessarily. The approach I'm using when I use it in class, I'm actually not using it this semester because I'm teaching a distance course and it's not compatible with the way I have to teach there. But when I do use it in class, I do quickly show them the demo. I want them to get a feel for what it's going to look like when they are successfully running the demo. So that, that's, okay, this is the kind of thing you're going to see. These are the kinds of questions the exercise is going to ask. And then I send them off. That has a nice additional benefit, by the way, that a lot of the ones I send off and they go and sit and play with themselves go even deeper than the exercises require. They go and explore various avenues, particularly in the parsing demo, not so much in the lexical one for whatever reason. The students can download all this software. I also give them the option of going to a lab. I have it all set up with a TA who knows what he's doing, and they can go and do that. I do have some other demos that I'm in the process of trying to pull into the curriculum itself, but none of them are as beautifully tied in with some of these core concepts that we teach as these two demos. So they're still works in progress. So I've taught that I've used this for 2 different semesters, and I've sort of surveyed the students afterwards, and the reaction I've gotten is what you might expect. They either love it or they hate it. If they hate it, a lot of it has to do with, I had to download this big piece of software and install it, and I'm not real good with Windows, and it didn't work, and then it wouldn't do it until the TA then said I had to move some DLLs around and this kind of thing. So there's some mechanics to be worked out in order to make this nice and pretty. The ones that successfully installed it and ran it at home tended to be the most satisfied, however, because then they could sit whenever they wanted to in the comfort of their own home, their jammies, whatever, and explore. Those are the students that tended to like it the most. I think they were also the most technically competent ones as well, the ones that we have a lot of students who are what you would think of as non-traditional. They come after 15, 20 years of real work. back in to get a master's degree. And those are the ones that actually find this kind of fun. But again, those are the ones that are most comfortable looking at, 2,000-line modules, that kind of thing. It's a little intimidating, I think, for some students. And those are the ones that did love it. Again, the hate tended to go with the setup, not as much with what it was they were doing. So what are we thinking about doing next? Well, one thing I'm concerned with when I do something, when I add something new to a class, is whether there's any value added. Is this just punishment for them, or are they actually going to learn something new? I'm not really opposed to punishment, but I also want to make sure they're getting something out of it. And so one of the things I would like to be able to do next is assess how much value there is added when we do this. However, this is not my area of expertise, so I'm still trying to sort of find how do you measure student learning, and how do you measure whether they've learned more? How do you set up an experiment? I don't know if anybody here has ever done that. I'd be happy to hear suggestions. But when I did this at SSCLI, which, Computer Science Education Conference, I didn't get very many suggestions there. So, but I've got to try to find out whether it makes any sense to continue it. It's a lot of work. The TA really has to know this, the Windows system, and that hasn't always been the case. My TAs haven't always known that kind of stuff. I'm also interested in sort of thinking about what additional tools might be useful. If I stuck a tool on top of the Visual Studio that showed people what the trees, for example, look like, or DFAs associated with the lexical analysis, and they saw these side by side, would that increase the learning? Would that mean I could bring it into the classroom as well? Another thing I'm interested in doing is seeing how well I can expand this to other things. In addition to the standard compiler course, I teach the second compiler, the back-end compiler course. And so trying to find out how useful, how to do that is something I'm interested in. And obviously I'll have to get a copy of John's book to do that. There's also some interest with some of our distributed systems people as to how they can incorporate the similar kinds of things into their classes. So see, Mark, I'm well under. I always talk too fast. Any questions? Yes?
Before they look at real-life compiler, is it not desirable that the students have an overview and an understanding of a compiler at various stages? Because as long as it's lexical analysis, perhaps it's manageable. Once you go to the parser, things may be more complicated.
Why I'm doing this in the context of the full semester class. So, for example, so far I haven't gotten to parsing yet. In fact, that's not true. I've got sort of the fundamentals of parsing. Next class, I'm going to talk about LL parsing, and I'm going to show the demo. So I do it in conjunction with the material, and that's actually one reason why I haven't done some of the demos that this student, at a great deal of sweat and time developed. It was because it's harder to tie it directly into the lectures themselves. I don't want to just make them do busy work and go through the compiler. I really am trying to tie it directly into the technique. So when I talk about LL parsing and we draw trees and we look at grammars and we look at the algorithm, hopefully then I can say, okay, well look, here, what would the trees look like? We know what the algorithm is. You can actually watch it parse and figure out what the tree looks like. So I am trying to pull it all together. Yes?
Are your students really able to cope with all the syllabus, because you have this by hand lexer and parser, LL, and then Jack, LA, LR, and so on, and just in a semester to touch all these things?
What's a lot? But remember, I actually have a follow-on course, so I really don't give them a lot of optimization. I think they get one lecture on optimization, one on code generation. So I've got lots of time. Are they able to? Some of them actually seem to really like this because it is, it does show them things that I only talk about in class. Hand coding scanners, and I don't really make them do that, partly because I hate doing it. I let them use tools, but then they actually get to see a hand-coded scanner. See, people really do it. It's just painful. So far, so far the students who don't like it, doesn't seem to be because of the, well, who knows? Maybe they think I'm reading their evaluations before I assign grades, but it doesn't seem to be because of the complexity. It's because of mechanics so far, and maybe they never get beyond that just to the complexity.
And do they still do the implementation of a
Yeah, I actually have them, I make up a new toy language every semester and have them generate actually SPIM so that they can run it in the SPIM interpreter so they can write, a program and it generates SPIM and actually watch their stuff go. So, I mean, it's not, for the faint-hearted, but it's one of our core classes that all our grad students have to get through to continue on. And I don't think it's unusual for a compiler class to be like this. So, I don't think anybody's ever thought compiler classes were the easiest things around. So, I remember doing all-nighters. So should they.
I was thinking you used Visual Studio. If you wanted to use the debug CLI, you can have a simple setup, less licensing things, and less user interface.
Right, and that is one option. I mean, it's not tied to either this particular compiler or this particular debugger, the overall approach. One reason why they were chosen was because, when I started getting interested in this, I was working with this Microsoft evangelist, and he said, well, let's try it with these things. They were willing to support my development for me to look at these. Yes, it's possible, other debuggers, other compilers as well. I wanted a debugger, though, that did have a lot of features, things that they could see. Something like GDB, for example, where you'd have to type all this stuff. There's no way that they would, at least I don't think they would get as much out of it. It's possible I could design it. But this, other than the mechanics of getting it all set up and integrated together so that the debugger really could run on top of the compiler, seemed to be a nice fit and show the things that I need to have shown.
So I had particularly in mind the debug CLI, which comes for free with the .NET framework, which is pretty much the same as the debugger inside.
Yeah, I haven't looked at that one. I probably should.
So it's actually, it has most of the features, I think.
Yeah, well, and this is free for students too. The Microsoft Academic Alliance, they can get a copy of that. So.
Yeah.
And they're usually pretty excited they're getting a free copy of VisualStudio.net. So I think half of them do it just for that.
Other questions?